Ever since the 1970s, astronomers have known that at the heart of nearly every massive galaxy, there's something truly extraordinary: a supermassive black hole. These titans of the universe are millions, if not billions, of times more massive than our sun, and they are surrounded by swirling clouds of gas, dust, and stars. But black holes aren't just these mysterious, dark entities that devour everything in their vicinity. In fact, some of them are launching colossal jets of energy, propelling matter at nearly the speed of light, stretching across thousands of light years into intergalactic space. These jets are so powerful that they can actually shape the galaxies around them. But recently, something truly surprising was observed by a team of astronomers using the Hubble Space Telescope. These black hole jets may not just be destructive forces. They might also be responsible for creating new stars along their path. Yes, you heard that right. Supermassive black holes, the very objects we associate with destruction and chaos, could be playing a part in the birth of stars. Now, to put this in perspective, let's talk about one of the most famous supermassive black holes we know, the one at the center of the M87 galaxy. M87, located around 53.5 million light-years away, is a behemoth galaxy, and its central black hole, which we've even imaged thanks to the Event Horizon Telescope, is about 6.5 billion times the mass of our Sun. It's one of the largest black holes we've ever observed, and it's producing a jet of high-energy particles that stretches across space for about 3,000 light-years. Just imagine that. A jet of material blasting out from the poles of the black hole, traveling at nearly the speed of light, extending across an immense stretch of the cosmos. For years, scientists have been studying this jet, trying to understand how it affects the galaxy around it. And recently, a team led by Alec M. Lessing from Stanford University made a groundbreaking discovery. Using Hubble's near-UV cosmic origins spectrograph, they observed something truly unexpected: nova explosions happening along the path of the jet. What's even more shocking is that they found twice as many nova explosions along the jet's trajectory than they did in the rest of the galaxy. Now, before we dive into the implications of this discovery, let's quickly explain what a nova is. In astronomy, a nova is an explosive event that happens in a binary star system. That's a system where two stars orbit each other. In this case, you've got a white dwarf, which is a very dense, compact star, paired with a red giant, a much larger and cooler star. Over time, the white dwarf siphons off material from its companion, pulling in gas and dust, mostly hydrogen. When enough hydrogen has built up on the surface of the white dwarf, it triggers a runaway fusion reaction. And boom, you get a nova eruption. This isn't a supernova, which is a different and much more dramatic explosion, but it's still an incredibly powerful event. What makes the discovery in M87 so intriguing is the fact that these nova explosions are happening near the black hole jet, in numbers that are far greater than in other parts of the galaxy. This begs the question, why? What's going on near this jet that's causing these star systems to explode more frequently? The team considered a few possibilities. One theory is that there are simply more nova-producing star systems near the jet. Maybe, for some reason, there are more binary star systems in this region of the galaxy, which would naturally lead to more nova explosions. But there's no evidence to suggest that this is the case. So, the next logical step is to think about the jet itself. Could the jet be influencing these systems, causing them to erupt more often? One possibility is that the jet is heating up the red giant stars in these binary systems, causing them to expand and lose more material to their white dwarf companions. But after careful analysis, the researchers concluded that this heating effect wouldn't be strong enough to account for the increased number of nova explosions. So, what else could it be? Alec Lessing, the lead researcher, and his team think that the jet might be doing something a little more subtle, something that we don't fully understand yet. One idea is that the jet could be somehow increasing the rate at which material is transferred from the red giant to the white dwarf. It might not be a direct physical push, but rather an effect of the radiation and energy that the jet is releasing. If the jet is delivering hydrogen to the white dwarfs more quickly, it would cause them to erupt more frequently. Essentially, the jet could be fueling these novae, speeding up the process that leads to these explosions. It's a fascinating concept because it means that supermassive black holes these cosmic monsters that we often associate with destruction and chaos, could actually be playing a role in triggering the creation of new stars and stellar phenomena. The jet from the M87 black hole might be snowplowing gas and dust onto these binary star systems, helping to feed the white dwarfs and trigger nova explosions more often than they would normally occur. But what's even more exciting is that this isn't the first time astronomers have noticed unusual activity near the M87 jet. In fact, shortly after the Hubble Space Telescope was launched back in 1990, astronomers used it to study the M87 black hole with its faint object camera. At the time, they observed some transient events, brief flashes of light that they thought might be nova explosions. But the camera's field of view was too narrow to tell for sure. They couldn't compare what was happening along the jet with the rest of the galaxy. Fast forward to today, and with the upgraded instruments on Hubble, we now have a much clearer picture. Thanks to this 9-month observation campaign, which allowed astronomers to look at the environment around the jet every 5 days, we now know that these nova eruptions are much more frequent along the jet's path. What does this all mean for our understanding of supermassive black holes and their role in galaxy formation and evolution? Well, for one, it challenges our previous notions about the destructive nature of black hole jets. Yes, these jets are incredibly powerful and can blow huge amounts of gas out of galaxies, potentially stopping star formation in some cases. But at the same time, they might also be contributing to the creation of stars, at least indirectly, by influencing the binary star systems that produce novae. This adds a new layer of complexity to our understanding of how black holes interact with their surroundings. And of course, this discovery opens up a whole new realm of possibilities for future research. Now that we know that black hole jets can have this kind of effect, astronomers will want to study other galaxies with similar jets to see if the same thing is happening there. Could this be a universal phenomenon, or is it something unique to M87? Are there other ways that black hole jets might be influencing star formation and stellar evolution in their host galaxies? These are the kinds of questions that astronomers will be eager to answer in the coming years. It's also a reminder of the incredible capabilities of the Hubble Space Telescope, even after more than 30 years in space. Hubble continues to deliver groundbreaking discoveries, showing us that there's still so much we don't know about the universe. And while we have new, more advanced telescopes like the James Webb Space Telescope on the way, Hubble's legacy is far from over. It's still revealing new and exciting things about the cosmos that challenge our understanding and push the boundaries of what we thought was possible. In the end, this discovery about the M87 black hole jet and nova explosions is a perfect example of how science works. Sometimes you go looking for one thing and end up finding something completely unexpected. It's these kinds of surprises that keep pushing astronomy forward, forcing us to rethink our theories and look at the universe in new ways. And who knows what other secrets are waiting to be uncovered in the depths of space? One thing is for sure, with tools like Hubble and the new generation of telescopes coming online, the future of astronomy is brighter than ever.